to our training today on Modbus data acquisition. In our Modbus data acquisition training, we'll start with an introduction. We'll go over what Modbus is, how it works, the differences between Modbus RTU and Modbus TCP, how different kinds of Modbus equipment works, applications where Modbus data acquisition equipment is being used, and at the end we will answer any questions. If you have any questions at any time, please enter them into the chat box and we will address them at the end of the training. My name is Maria Lamoni and I've been with the company about 9 years. I'm the sales manager and have previously held positions of application engineer, technical sales engineer, and web developer. I also have Khan with me from our technical support department who has over 5 years experience in the automation industry. He's going to be giving an online demonstration of easy data logger, control, and monitoring software with Modbus TCP I/O devices after I introduce Modbus. ICP DAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP DAS USA was launched in 2001 to support the North and South American markets. We have over 100 R&D engineers and work closely with them to add new features to our products, develop new products, and to support our customers. Most of our products are RoHS compliant, which means they're lead-free. We have our ISO 9001 certification, which ensures we meet product statutory and regulatory requirements. Modbus is a simple and standard, robust serial-based communications protocol that's widely used for industrial communications for instrumentation, control, and data acquisition. It was originally published by Modicon in 1979 for use with its PLCs. Modicon is now Schneider Electric. Modbus is an open communication protocol that has been managed by the Modbus organization since 2004. It is openly published and royalty-free. Data acquisition is the process of sampling real-world physical information and the conversion of those samples into digital numeric values that computers and controllers can understand. Programs can be run on computers and controllers. They can take that information and implement control logic operations like the turning on of a fan based on a temperature, turning on a pump based on a tank level, or opening a valve based on pressure levels. Modbus RTU and Modbus TCP are protocols or languages that devices can communicate over. RS-485 or Ethernet refers to cabling that protocols can communicate over. Sensors are attached to data acquisition equipment, which can provide information that a computer or controller can use. And in this picture here, you can see the PC is running software like Easy Data Logger control and monitoring software. It's connected through an Ethernet cable to an Ethernet switch, and then that Ethernet switch is connected to the Ethernet port of an analog input module. Then you can see there's a little terminal block at the bottom which can be connected to the power input. And then the I/O terminal block at the top, you can see there's a connector for a thermocouple sensor and also another connector for a fan, so you can trigger the fan based on the temperature. Modbus RTU allows for communication between up to 255 devices in one network. For example, a computer can collect temperature and humidity levels from Modbus RTU-based devices in many different areas in a building or manufacturing plant. Modbus is often used to connect supervisory computers with RTU remote terminal units in SCADA supervisory control and data acquisition systems, so you can see the status of the equipment on a PC. It's also used in applications like energy management, machines, remote monitoring systems, wastewater processing systems, and building automation systems. Modbus applications are easy to deploy and maintain. Each Modbus device in a network is given a unique address. In serial Modbus RTU networks, only the node assigned as the master may initiate commands. In the Ethernet-based Modbus TCP networks, any device can send out a Modbus command. One master device is usually configured to send Modbus commands. A Modbus command contains the unique Modbus address of the destination device. Only the destination device will act on the command, even though others might receive it. All Modbus commands contain checking information that ensures commands arrive intact. The basic Modbus commands can instruct an RTU to change a value in one of its registers, control or read an I/O port, as well as command a device to send back one or more values contained in its registers. Modbus RTU-based equipment communicates over RS-485, which communicates over two copper wires that are usually twisted around each other. Modbus RTU supports communication distances up to 1,200 meters or 4,000 feet without a repeater. Greater distances can be achieved with a repeater. There are different speeds at which Modbus RTU devices can communicate, like between 1,200 and 115,200 bits per second. Modbus TCP protocol is a variant of Modbus RTU protocol. It was developed in 1999 to allow Internet and Ethernet access of Modbus devices. Modbus TCP-based equipment communicates over Ethernet cabling. Many buildings have Ethernet cabling pre-installed, so adding Modbus TCP devices is convenient in many applications. Modbus TCP and Ethernet cabling supports communication distances up to 100 meters or 328 feet. Additional distances can be achieved if you add Ethernet switches like NS205. We provide a wide selection of industrial DIN rail mountable Modbus RTU, Modbus TCP-based data acquisition equipment including thermocouple, voltage, current, thermistor, RTD, digital, and relay output types. In this picture here you can see over RS-485 twisted pair cabling. You can connect different kinds of Modbus RTU devices in a daisy-chained fashion. We have the M7000 series, and we also have the TM series, which is about half the size of the Modbus M7000 series. The difference is you can piggyback mount the M7000 series up to 3 high. So you can mount them all on a DIN rail up to 3 modules, and then the tiny ones are smaller and they don't have the piggyback feature. And they also have different I/O configurations. Down here you have an Ethernet switch connected to a computer all over Ethernet cabling. And you see this here, this is the ET7000 series with one Ethernet port, another ET7000 series with the one Ethernet port, and then we have the ET7200 series, which has 2 Ethernet ports, which supports the Ethernet-based daisy chain configurations. Our Modbus RTU equipment is set up on a computer with Decon Utility, a software utility which allows you to search the network, configure addresses and I/O types, baud rates, parity bit, checksum, and to test the input and output status. Decon Utility can communicate with Modbus RTU-based equipment through a COM port, or virtual COM port that is set up with an Ethernet to serial converter. M7017 is a Modbus RTU-based analog input module that can measure voltage. It is widely used in the energy industry with solar panels, wind turbines, and inverters. The solar panels and wind turbines produce DC direct current energy. Inverters convert the DC direct current energy into AC alternating current that can be fed into a commercial electrical grid. DN843i is a current input sensor board that can put out voltage. M7017 can take that voltage so it can be brought back to a computer for data logging, control, and monitoring so you can measure energy being produced. The data is logged on a WinPack WP5141XW107 programmable automation controller with Windows CE.NET 5.0 operating system and VGA port for connecting to a monitor. It supports Modbus. We provide free eLogger software that allows you to set up simple control, monitoring, and data logging applications. Data from the WP5141XW107 can be sent back to a SCADA system over Modbus TCP. Modbus TCP-based analog data acquisition modules like ET7217, ET7218, and ET7244 communicate over Ethernet cables and have 2 Ethernet ports for daisy chain topology. You can use industrial Ethernet switches like NS205 with them if you have a lot of Ethernet devices in your network. They have a web server inside for configuration. We also provide free mini OS7 utility for setting their IP address information and for uploading new firmware if needed. You can also upload images to our Ethernet I/O devices and show the images inside of the web server through the web interface. For example, if you were monitoring tanks, you could have a page in there that shows a graphic of a tank above the actual tank level data, so it's clear to the viewer what the data is showing. Or you can show a picture like this one here, which shows what the I/O is connected to. You could show the status of valves, motors, pumps, and temperatures. You can use a standard web browser and the module's IP address to pull up the web server for configuration and monitoring. To set up Modbus TCP-based data acquisition devices like the ET7200 or ET7000 series, you can connect them directly to a PC with an Ethernet cable, or you can connect them to a switch or hub to get them on your network. You can use Mini OS7 utility to set the IP address of our Ethernet controllers and data acquisition equipment so they can be used with other Modbus TCP devices. Modbus TCP-based equipment needs to be on the same network, so each device needs a unique IP address. Each device needs to have the same subnet mask and gateway. To access the web server for the ET7000 series, you can open a standard web browser, enter in the configured IP address, then enter in the username and password. You can configure the I/O settings, create different users with passwords, make web pages for displaying data, and change network settings. Modbus TCP-based ET7000 series are being used in emergency warning systems. They are just like the ET7200 series, but have one Ethernet port. They are connected to devices like cameras, smoke sensors, and transmitters. They send signals over the internet to remote devices like web-based LED displays and display warnings to drivers about dangers in tunnels and can direct drivers to a better route to keep the roadway safe. Cellular controllers like G4500 can operate over 2G or 3G cellular networks and support Modbus protocols. They can be programmed in C language and allow for sending of text messages and emails based on information from data acquisition equipment. Zigbee is a self-organizing mesh network that was developed for applications that require a low data rate and secure network. It was developed in 1998, and the name originated from the way honeybees fly back to their beehives. Zigbee wireless I/O modules communicate over Modbus RTU protocol. They need a host converter so they can communicate back to a PC or controller. They're set up with some dip switches on the side of the product so they can be in the same wireless network and have a unique address. Zigbee wireless devices are ideal for applications where wiring is inconvenient. They are used in applications like building, factory, and machine automation. Each Zigbee network has one RF channel and one PAN ID. Each node has a unique node ID. Zigbee supports many flexible topologies like cluster, where nodes are arranged around the host converter in little bunches, mesh, where the host coordinator is at one end, or star, where the host coordinator is in the middle. We provide Zigbee Alliance-based products that work with other vendors' Zigbee Alliance-based products. At the bottom right of this image, you can see a host converter is connected to a PC. Each Zigbee network needs a host converter to act as the coordinator for the network. It helps to establish the communication path between computers and end devices. The PC holds a monitoring and control program so operators can see the status of factory, and they can also turn things on or off as necessary through the program. To the left of the host converter, you can see a Zigbee I/O module, which can be used to turn things on or off based on conditions. At the top right of the picture, you can see a Zigbee slave converter is attached to a touchscreen HMI human-machine interface. With it, users can input things like the number of pieces of materials a worker cut with an industrial saw. The image also shows other I/O modules and devices connected to the wireless Zigbee network for providing information for control and monitoring. Data logging allows for the recording of values like tank levels, water flow, and temperatures, along with the time and date. It allows you to save information like tank 1, 3 gallons, 10:15 a.m., May 29, 2015, in CSV format that can be opened in Excel. Energy management systems help with monitoring power consumption and energy usage. Monitoring energy can help save on costs, since changes can be made to reduce energy usage when it's not needed. SCADA control and monitoring software can be used to display the data in a way that's easy to understand and analyze. We provide Modbus RTU-based power meters that can be used together, kilowatt hours and energy consumption data. You can daisy chain many power meters together over the RS-485 bus, and you can send the information back over the internet with cellular modems. Power meter concentrators can be used for logging and displaying power meter information. Data logger devices like power meter concentrators allow information to get logged on a micro SD card in a CSV, separated value format that can be opened in Microsoft Excel. WISE data logger controllers allow for real-time automatic control and data recording from local devices. They log onto a micro SD card. WISE 5800 interfaces with Modbus RTU devices. WISE 5800 MTCP logs from Modbus TCP devices. They both can be used with SCADA software and can send out email alarms based on conditions like high tank levels, high temperatures, or low pressure levels. The new WISE 5200 series can collect data from both Modbus TCP and Modbus RTU devices. These all can be used as standalone Modbus data logging systems. You can use FTP to get the data logs, or you can swap out the microSD cards. Modbus TCP communicates over Ethernet networks. Modbus RTU communicates over serial networks. These two networks are not the same. You can use a Modbus RTU to Modbus TCP converter like TGW715 to combine networks. You can also use RS-485 to Ethernet converters like TDS715 in case your computer doesn't have a serial COM port. They are set up with a software utility and allow you to communicate with serial devices over Ethernet networks. Easy Data Logger is a free PC-based control and monitoring software that we provide with our data acquisition modules. You can use it to send email alarms based on conditions, log data, show information on a screen, or to implement control. You can use it with other vendors' Modbus products as long as you have one ICP-DAS Modbus product in the network. It supports up to 64 I/O tags, which are words tied to memory locations in the computer that represent the input and output channels from data acquisition equipment. You can also display and log video from web cameras and can send SMS or email alarms out based on information from the system. You can also set up virtual channels that can hold information, like if you want to take 5 channels, then take the average, you could use a virtual channel to hold the average. Easy Data Logger supports layout pages, so you can get graphics from the graphics library and map them up to I/O equipment so you can visually see the status of tank levels, pressure readings, or the status of valves, motors, and other equipment. It supports trending so you can see the status of equipment in a graph over time. You can also log the data in Access or a SQL database. You can export the data to Excel or CVS, separated value files. An advanced version is available that can support more channels, alarm contacts, and web cameras. You can use Easy Data Logger for standalone Modbus data logging, control, and monitoring applications. SCADA is supervisory control and data acquisition. SCADA software runs on a PC and allows you to interface with various equipment like data acquisition modules, PACs, programmable automation controllers, PLCs, programmable logic controllers, embedded controllers, and instrumentation devices. It comes with a graphics library that you can use to create a visual user interface that represents real applications. They also support scripting, so you can implement some control through some basic programming commands. They support multi-level user management for security. Different users can have different permission levels. Different users can access different areas of your system. In this picture here, you can see that there's 3 different areas that each have a PLC connected to a touch panel and some data acquisition modules. They're connected to a hub or Ethernet switch and a camera. They're networked back over Ethernet cables to a PC running Indusoft SCADA software. You can monitor and control the system from each area or from the PC running SCADA software. Intusoft has multi-language support, so you can create your program in English and then easily convert the system to another language like Spanish. We provide some PAC programmable automation controllers that have Intusoft built in. SCADA software can be set up to be web accessible over a web page and can automatically send email and SMS alarms. If you're going to send SMS alarms, then you can use a cellular modem to send those out. GPRS data servers like GT540 are configurable and can allow software on a PC to communicate with Modbus RTU-based devices connected to GT540 through the Internet over the cellular network. They also have 1 analog input, 2 digital outputs, and 6 digital inputs on board for data acquisition. They can send email alarms based on configured high and low alarm levels. M2M RTU Center is software we provide that allows SCADA or other programs on a PC, like Easy Data Logger, to easily interface with remote data acquisition devices through our GPRS data server devices like GT540 or G4500. It's an RTU series management tool that supports up to 128 GPRS RTU devices. This M2M Center software is free. We also provide an advanced version at a cost that supports up to 1,024 devices. Modbus Pol is a very popular Modbus master simulator that can be used for testing and debugging of your slave devices. It supports Modbus RTU and Modbus TCP protocols. It allows you to test and simulate Modbus protocol. You can use it to monitor several Modbus slaves at the same time. Modbus Slave Simulator allows you to simulate up to 32 slave devices in 32 different windows. It's convenient for PLC programming, so you can test before you receive your slave devices from your supplier. You can use it to monitor serial traffic. It also provides OLE automation for interfacing with Visual Basic and Excel. It allows you to do things like read the coil status, input status, holding registers, input registers, and write to registers. Modbus is a C# 3.0 implementation of the Modbus protocol. It is developed and maintained on a voluntary basis and is provided free of charge. You can use it to help develop programs, and many demo programs are available. ICP-DAS verified and improved the DLL based on the official released version nModbus_net-2.0_1.1.0.0-source.zip. Programmers can use the DLL released by ICP-DAS to provide applications for regular Windows-based PCs or WinCE-based devices. The DLL features Modbus RTU master slave, Modbus ASCII master slave, Modbus TCP master slave, and Modbus UDP master slave. We provide Modbus-based software development kits with our controllers that can be found on each controller's product page on our website under Product Reference and Support. Software demo programs and development kits are also located on our website under Product Support and Documentation. We provide training videos on our website that include programming tutorials. We provide Modbus demo programs for our touchscreen controllers that include touchscreen PLC as a Modbus master, as a Modbus slave, reading data from Modbus slave devices like power meters, and controlling Modbus slaves which trigger fans and lights. WinPack comes with CE.NET operating systems and supports Modbus protocols. We provide demo programs and development tools that make development fast and easy. Wise series products don't require any programming, but allow for implementation of if-then-else type logic through drop-down selections in a web browser. We provide a tutorial section on our website that has step-by-step procedures for using digital and analog information to trigger digital and analog outputs, send emails, synchronize time, log data, and implement recipes, which are sequences of actions that can get triggered. We also provide other controllers that support Modbus and come with demo programs for Linux or CE.NET. Also, we have a Mini OS 7, which is a DOS-like programming operating development environment. We also have demo programs in C language, ladder logic, IEC 61131 languages, and more. Software development kits, tutorials, and training videos are available in the support section on our website. These are some Modbus resources that can help you with information on Modbus and tools for testing and communication with Modbus equipment. Later today, I will send you all the slides from this presentation so you'll have all of these resources available. So while I'm transitioning over to Khan for a demonstration of Modbus equipment with SCADA software, I wanted to mention some of our company benefits. They include OEM capabilities, low lead times, and personalized care. We also provide industrial products at competitive prices and keep up with the latest technology. We offer free technical support and offer a wide variety of modular solutions that meet many different kinds of application requirements. So now Khan is going to show you a demonstration of Modbus equipment with SCADA software.
Today I would like to show you our easy data logger with one of our ET7017-10 data acquisition unit, Modbus TCP supported. Here, this is our easy data logger main screen. We can create a new project here. Today I already created one project. Today I would like to show you this project right now. And here I can click on the group settings. Here we are going to click on install and to install new device. Here we need to select driver mode, which is Modbus TCP, my device here. So we just need to type the IP address. I can type 192.168.10, and our port, it's a default Modbus TCP port, which is 542. Then I'm clicking new device. So here I already set up our device here, so we can select the slave device, which is our Modbus TCP device, ET. Whenever I select my device, I will be able to see here the channel numbers, so which is 10 channel analog input module. So I'm going to click add, and then close. So here I can close here. I just select all of my channels here and click add. Then I will see that I add my analog channels here on the right side. Now I'm going to click home. I just want to show you how we do communication. Here I have device studies, and whenever I click on start, I need to see green right here, which means I'm going to communicate to my module here. So I can click on the layout here. I will see my raw volume here. Then we are going to do scaling with this and all other channels. So basically I have a one variable power supply here. I can change the input value from 10 to from -5 to 5 volt. And now let's stop this project and go to group settings again. I'm going to click my first input, which is already connected to my power supply here. So I can edit my component, which is shown on the screen. I can select angular gauge, or let's say linear gauge. Let's do linear gauge. I also need to do scaling. Since I have -5 to 5 volt, I'm typing here -5,000 to 5,000. And I would like to show you between -5 to 5 volt. Here, just type 5, click calculate, and I see the scaling values here. And I'm going to click modify, do this, then click home, and going back to project, I'm starting my project running again. Then I saw that I have communication, and click on the layout. Oops, we missed this part. I also need to do okay. Okay, here it is. Okay, I'm going to start the project running again. I'm clicking on the layout, and we see our value here. Let me also show you the changes. I can see the value here also. That I'm applying input channel. I increase my voltage from 0 to 5. There we go. Okay, here it is. So I was going to, I already added -5 to 5 volt, and now I'm applying 5 volt to my input. So also one other functionality of Easy Data Logger is database settings. I also would like to show you how we do database settings. Here I clicked on system configurations, and we can determine our sampling rate, our graphic axis, which is 1 second is enough, I guess, for now. My data format is 123.44456, and I'm going to. We can also select a file here for alarm, also the data file path here, which is also under log file lab, and I save here. Also we can do same settings for SQL server and MySQL server connections. If you have any questions with this, we have quick setup guides which I can send right after webinar. So I'm going to click on save, then fix it, and I do run my project again. Let's click on the open database and select the file. We are going to select our file from the file path, and it was the first group, work group. Then we are able to see our channels here. I just select first channel, which I already wired, and okay, about the trend table. Here it is. So basically, I start from 1, then I went to 0, then I came to 5 volt, which we can see on the database here. And we can print this file if you like to, or we can export to Excel. And I close it here. Is there anything else that I can also show you? I also can show you how we do registration. We just click on the About. Then we should be seeing if you are the first user and just download it, you should be seeing here blank. Then you need to click on the Enter License. Then we can see the Enter License page here, and just type the information on your file which you downloaded from our website for the free license key. I guess that's all for now, and I pass over to Maria again. And if you have any questions, please just type on the chat box, and I will answer right away.
Okay, so thank you, Khan. That was great. So I got some questions here, and I typed in the answers to some of them, but I'll also go through them. So the first question is, will this webinar or presentation be available for offline viewing at a later date? Answer is yes. I included the link there to where the webinar will be on our website. The videos on that page that I put the link for, the videos are listed in alphabetical order on the right side. This video that's going to be posted will be called Modbus Data Acquisition Training. Later today, I will be emailing you all the slides. Charles had asked, are the slides available for download? So later I'm going to be emailing them all to you with the email address that you used to register for this training. Shakar asked, what is the piggyback configuration? The piggyback configuration is when you take the little clip that comes with each module, unscrew the screws that hold the case together, mount the clip that came with the module, then put the screws back on and mount one module on top of another onto that clip. Edgar asked, is it possible to mix ICP devices and third-party Modbus devices to Easy Data Logger software? The answer is yes. As long as you have one ICP DAS device in your network, you can use the other vendor's Modbus devices with Easy Data Logger. Edgar also asked, how much are the Modbus tools? I believe the Modbus tools are free. You can use those links that you'll be getting later today to see. Shakar asked, what is Modbus SDKs? Modbus SDKs are software development kits that allow you to quickly and easily develop programs for applications. The message is gone. There was a question about what's the difference between Modbus RTU and Modbus TCP. Modbus RTU allows you to communicate over serial networks like RS-232 or RS-485, and Modbus TCP communicates over Ethernet cabling. Also, a Modbus RTU uses different kinds of communication parameters like a baud rate, parity bit, checksum, and the address is usually, like something like 1 or 0 up to 255. And then Modbus TCP devices have an IP address. The communication distances is another thing. The Modbus RTU-based equipment can communicate up to 4,000 feet without a repeater and greater distances with the repeater. And then Modbus TCP communicates up to 328 feet, but you can communicate greater distances with the switches or repeaters like hubs. Let's see. And then there was another question. Maybe Khan, you might help explain this one. Tim asked, how do you choose which device to set up as a master or slave? Usually the master could do some sort of control or polling to do some action based on the information or maybe log the data. But the way to set it up would be different based on what you're doing, like with SCADA software or with a controller. Khan?
Yeah, I can say, I have such a description for this. Which device is active device can be master, which device is passive device should be a slave device, which means your active device should be asking for the data and receiving the data, and slave device is usually just sends the data and receives the data which needs to be processed. So basically, SCADA software is usually either master programs for the applications or our PLC can be set up as a master or slave. It depends on the application the customer is using.
Okay, and then Don asked, what is the range of the Zigbee wireless devices, and is it shorter, communicating through several walls? So a lot of our Zigbee equipment, the default communication distance is like 700 meters,
Right.
And you can use antennas to extend the operating communication distance up to several kilometers. And each end device in the Zigbee network acts as a slave, so it repeats on the signal. So depending on how you lay out the topology and the layout of your devices in your application, for example, if you laid them all out in a row, each end device is acting as a repeater, so you could have the communication get extended without extra repeaters and antennas if it's all within the 700 meters. If you are communicating through several walls, it depends on the kind of wall. If it's like a steel wall, then the communication signal may not go through at all. But if it's just regular office walls, then it's similar to Wi-Fi. It does operate over the same 2.4 gigahertz band, so the signal can go through. We've tested it, for example, at different offices, and it does go through. And yes, just based on your building or your environment, you may want to add more repeaters or devices in your network. If you do have Wi-Fi networks at the same location as Zigbee devices, since they do operate over the same 2.4 gigahertz band, you may want to use a different wireless method like RF modems for the communication to go on a different wireless frequency. That way the communication won't have any traffic. Any input, Con?
I think, yeah, I was gonna say the same actually. So it's 700 meters for line of sight, but we can extend our distance by using the antennas. That's, I guess, 15 kilometers. But yeah, wall thickness and wall type is really, really important for the signal strength.
And then another question Shakar has is, how do we decide if we want to use Modbus RTU or Modbus TCP? You want to go ahead and answer, Khan?
Oh yeah, he can directly contact to us by sending his application, and we can decide which one should be Modbus or what kind of application he's using. He can use the both way in the same application. Actually, he can use Modbus RTU devices with the Modbus TCP devices. So it depends on his application, but I can definitely help him if he contacts us.
Okay, and then, it's a little simpler to use Modbus TCP because Ethernet cabling, you can just buy an Ethernet cable to the right length that you want, and it already has the connector on each end. You don't have to use any kind of wire strippers. Then if you use Modbus RTU, you're going to want to use copper cable that's insulated. Then you use the little wire strippers to get the ends out, and you cut it to the size that you need, and you twist the pairs so there's a little bit more wiring involved, I guess, just one little extra wire. And if you want to use Modbus RTU, and then if you want a cabled application, the Modbus RTU can go up to 4,000 feet, which without a repeater or switch, and then so that communication distance is longer. Otherwise, if you want to go really long, you could use like a serial to fiber switch. We provide those, or Ethernet to fiber, and then you can tap into the fiber cable, which can go a lot greater length. Also, with the Modbus RTU, that communicates over serial RS-485, so you would need like a USB to RS-485 kind of product to be able to configure those devices with your computer, whereas Ethernet, then you could just use the Ethernet cabling and just connect straight to your Ethernet port on your computer, for example, to configure those. So that's an extra product that you may or might not want or need.
Right. I considered, I'm sorry, that customer might have an existing system which already supports Modbus RTU. So if customer has this kind of application, we can also use Modbus RTU device with our Modbus TCP devices and carry them through Ethernet communication.
Right. So if you already have a big network of Modbus RTU devices, then you can just add more Modbus RTU. Or if you already have Modbus TCP, you can add more Modbus TCP. Or like Khan mentioned, if you want to add TCP to the RTU networks, you can use a TGW715, which is a Modbus TCP to RTU gateway. And also for the TCP networks, if you want to add RTU devices, you can do the same. Another question from Don is, does the WP8149 automation controller allow you to telnet into it, or is it all done by a web server? Yes, telnet capabilities are provided, so you can do some things with telnet. You can also do things on a web server. So basically the WP8149 allows you to use Indusoft on there, and so Indusoft wouldn't be what you're telnetting with, but the WP8149 is a CE.NET 5.0 embedded programmable automation controller, and it does provide a telnet feature, so you can use telnet to interface with it. You can also use FTP server. You can use a HTTP server, publish it to the web page. It also has like SQL Server Express database. So there's a lot of tools there in that Windows friendly environment. And you can also opt not to have the telnet capability if you don't want that. Basically, it's like a different kind of operating system image that you're going to have in there based on your requirements. Does anybody else have any other questions? So later today, I will email you all the slides along with the questions and answers in the email. And if we can help you with any applications, please feel free to contact us anytime. And thank you so much for attending our training today. And we have these every twice a month, so hopefully we'll see you in the future. Thank you.